Today we're just going to have a look at this one bearings past paper question. Bit tricksy, actually very tricky, that don't leave good margins. Let's have a little think about what you're going to have to do. A captain rows out from S. He stops when he's 120 metres from S on a bearing of 140. Use the scale drawing below to find the distance and bearing from T when he stops. Okay, so we need to find the captain's position. To find a position we need a bearing, we've got 140, and a distance, 120. Two things we need. And then we find the bearing from T, so we're going to draw a line from T, work out the angle and all that sort of stuff. Right, so straight away we're into a bearing of 140 from S. Place little mark here over the dot which marks S. Place a mark here at 140 and draw your line. Remove, that's 140. Good, remove your protractor. Now we need to measure 120 metres on this map. Now we know that 1 centimetre represents 20 metres and we're looking for 120, so we'll divide 120 by 20 to find 6. 6 centimetres equals 120 metres, and so we get our ruler out and we measure 6, mark the spot, and that is where the captain's position is. We're scoring marks all the way along here now. We're going to draw a line through T, through our little dot, and we're going to measure it, which is 6.5 centimetres. So on this scale, that boat is 6.5 centimetres from T. How far is that in the real world? We're at 6.5 centimetres times 20, because this is a 1 centimetre to 20 metres, which is 130 metres. Good to know. Now let's find the bearing. We put our protractor in. We put it round this way this time. And we measure, using this internal one, what this angle is. So it's the little one here. It's 166. So we'll take that. That's 166. But that is not the bearing. Oh no, that's not the bearing. Because you measure bearings this way round. So we are looking for this angle. So realistically, we're looking for bearing, which is 360 minus 160. We want this distance around here, and that is equal to 194. So we can write 194 in here, and you can see it's right because halfway round is 118. It's gone a little bit further. So 194. So to summarize, the bearing is 194 degrees. The distance is 130 meters. Now, if I wanted to check this, there's all sorts of nightmarish trigonometry I could use, but it's just ridiculous and overcomplicated. I'm afraid the only check is to remeasure it. Check your angles, check your bearings, and all that sort of stuff. Hopefully, if there's any errors, you will spot it. So what have we done? First of all, we've had a little think. This is a hard question. Don't go flying in. I've got to work out what I'm doing first. I will get marks for getting this cross in the right place, but it needs to be quite close. They allow you, one or two degrees out and a little bit of distance, but not much. And then I do the calculation, and then I check it and hopefully find it's right. Anyway, best of luck.